Okay, here we go. We're doing the partial practice test for writing equations of linear functions, and I'm hoping that you're checking your work as I'm going through them. On the test, you're going to see problems like number 1, where you can tell that there is a y-intercept. In this case, the y-intercept is 7. And you can figure out that the slope is up 1, 2, 3 over 1. So we would first put a 3, but then we would remember, if I write my name on the line, I'm going downhill, so really it's a -3. So on these problems where you can recognize what the y-intercept is and figure out the slope, then you plug it all into the slope-intercept form, the short form, y equals mx plus b. So we'll have y equals -3x plus 7. Okay, moving on. When we see a line that's straight up and down, we know that that is an x equals something. And so we look on the x-axis and we see that it goes through the point -5. So this line's name is x equal -5. And sometimes you're going to be given information just in a sentence. And like this sentence, it gives us our slope and it gives us a point. When we're given the slope and a point, we use the longer formula that's actually called point slope. So we'll write down our longer formula, point slope formula, and we'll start substituting. So when we see m is 4, we're going to plug in 4. When we see m, we see the parentheses and the x and the minus. We're going to write all that. When we see h, that means we're going to plug in the 3. And when we see a plus k, -2 is the k. We're going to plug that in. So you see me writing a plus, a negative. Really, when we see that, what we want to do, we could keep it that way, but a plus negative is really the same thing as minus a 2. So we're going to distribute. We'll get y equals 4x minus 12, and then we just bring down the -2, the -2. And our last step is we combine these two like terms, so we'll have y equals 4x minus 14. Don't forget when you're distributing to distribute to that second term as well, and then combine those like terms, and the equation is 4x minus 14. Sometimes you might find tables that are lying down, and those are a little bit more difficult for us because we've always been doing tables that are standing up. Remember, your top, if it says input, that's your x, output's your y. And when we do hoops, instead of starting from the bottom, we start from the very right. And so as we do our hoops, -9 minus a -6 is -3. -6 minus a -3 is -3. -3 minus 0 is -3. And another -3. Now the problem with a lying down table is as we're doing our hoops, we notice that it's easy to make the mistake that my slope is 1 over -3, right? Because we see the 1 first, it's on top. We have to be really careful. Just like slope is rise over run, we know slope is always going to be my change in y. Okay, lost an n in there, change in y over my change in x. So that means my y has to come first, so my slope's going to be a -3 over 1. When we see that we have a fraction like this that can be simplified, we're going to simplify it. So our slope is -3. Okay, so we're going to use our slope. This table does not give us our y-intercept. If it did, that would make it easy, but it didn't. It gave us our x-intercept, 2, 0. If we graph that, that's going to be on the x-axis, not the y. So now's the point where now's the part where we pick a point. So we know our slope is -3, and then we can pick any of these points. We could pick 2, 0, or we could pick 1, 3, or we could pick 3, -3. We could pick any of those points. We try not to pick the points with negatives because why not? If we could pick an easy point, pick an easy point. So we can go ahead and pick 1, 3, or we could pick 2, 0. Why don't we pick 2, 0 and see what happens when we do have a 0? So once again, because we have a point and a slope, we're going to use a long formula, which is the point slope formula. So we're going to rewrite it. because once you get your information, then we're just doing the same thing over and over again, which may seem boring, but then that's good because on the test, you're just doing the same thing. And it's, you can do it once, you can do it 10 times. So we're going to plug it in. When we see y equals, we write y equals, but when we see an m, we're going to plug in a -3. When we see an x minus, we rewrite that, but when we see an h, we're going to plug in a 2. And then we see plus k, and k, when we plug it in, is 0. Kind of got in my way. I'm going to undo that real quickly. Okay, we're going to plug in and it's plus 0. And then after we plug in, we do the same thing. We're going to go ahead and distribute. -3 times x is -3x. -3 times -2 is +6. And we could bring down the 0, but then we quickly see when we combine these two last terms that it's just -3x plus 6. So if you got that right, great. If you didn't, why don't you pause this video so you can make sure you can correct your own mistakes and learn from them. That's what practice tests are for. If you don't make mistakes, that's great. But if you make mistakes, learning from those mistakes, that is so important. Very, very important. Okay, write an equation of the line in slope-intercept form that passes through the points below. Okay, so slope-intercept form is just getting it into the y equals mx plus b form, which is what we do each time anyways. So here we've got 2 points, and in class I taught you that an easy way to find slope given 2 points is just to put them in table form. So we put 2, 8 like that, and 6, -4 like that. And then we're going to go ahead and do hoops to find our slope. -4 minus 8 is -12. 6 minus 2 is 4. Once again, slope is rise over run. So it's change in y's, rise, y's. That goes in the top. That's on the bottom. So our slope is -12 over 4. And we can simplify that if we put it in our calculator and get a -3. So slope is -3, and then we pick a point. We have 2 points to pick from. Let's go with 2, 8. So we have a slope of -3 and a point of 2, 8. We are going to go ahead and write our long formula. Our slope-intercept, our point-slope formula. And here we go. We're going to plug it in again. When I see y equals, I write y equals. When we see m, we know we need slope, so we're going to plug that in. We see an x minus, we're going to write that. We see an h, we're going to plug in a 2. And when we see a k, we're going to plug in an 8. Now we're going to do what we do best, distribute, distribute, and bring down the plus 8. And the last step is we combine our like terms, and we have the equation of the line that goes through the 2 points that they gave us. Okay, for number 6, the y-intercept of the line that goes through the points -7, 0 and -9, 4. So we're going to do the same exact thing as what we did above. We see the 2 points. We're going to put them in table form. And we're going to do the hoops. So when we're doing our hoops, we have 4 minus 0 is 4. -9 minus a -7 is going to be -2. And so our slope is 4 over -2, which if we put that in our calculator, we're going to get -2. Then we pick a point. I'm going to pick the -7, 0 because it is nice to pick a point that has a 0 in it. And once again, since we know our slope and our point, we're going to use the long formula, which involves the slope and the point. And here we go again, doing what we do best. So we've got y equals, our slope is -2. We see the x minus, and then we know that our h is also a minus. So that's what's really important. I want to stop here for a second. It's really important when you're plugging in, if you don't write the x minus like we did, then you might forget that a minus negative is going to be a plus. So please make sure when you're plugging in, you always write your x minus and then put whatever it is that comes after it. And then of course we're putting 0 in for k. So the reason why we made a big deal out of that is if now that we have a minus a negative is actually a plus. So So now we've got, when we distribute, we're distributing negative 2 to x, and we're distributing negative 2 to 7. And of course, we could put the plus 0, or we could just leave it out because it doesn't matter anyway. Sorry, 0. You don't really matter. Okay? And, oops, if you did what I just did, which is like, okay, yay, I went ahead and got the equation, I'm done. But really what they asked for is they asked for the y-intercept. So let's stop. Our y-intercept is a negative 14, and that's what we'll write. Okay, so unlike the first graph that we saw in this packet, this graph does not have a nice y-intercept. And so instead of being able to use the y equals mx plus b, what we're going to do is try to find some corner points, and these corner points aren't too bad. We're going to go ahead and find our slope, and so it's going to be what? Rise up 1 and run 2, and then once again, if I write my name on this, I'm going to be writing it downhill, so the slope is negative. And then we're going to pick a point. So let's remind ourselves what the name of these points are. To get to this point from the origin, I go over 1 on x, and I go up 1, 2, 3, 4. So the name of this point is 1, 4. The name of this point, if I were to go to it, I'd go from the origin, I'd go over 3 for x, and I would go up 1, 2, 3 for y. The name of that point is 3, 3. And if I looked at this point, the name of it would be over 5 up 2. So we can pick 1, 4, 3, 3, or 5, 2. I'm going to go with 1, 4. So we'll go ahead, and once again, I think that if we're bored, that's a good sign, because if we can do this, then we can get an A on the test. And yes, we are going to use the long formula again. I guess that's the good news, right? If you can do this once, you can do it a million times on the test, and that's great. But if you can't do this once, then you're really going to struggle with the test. So it's really important to get this down. And so when we're plugging in, I see the y equals, I write the y equals. I see the slope, I'm plugging in the negative 1/2 for the slope. I see the x minus, I'm going to write it. I see the h, I'm going to plug in the 1 for h. And I see the k, I'm going to plug in the 4 for k. And then I'm going to do the same thing. I'm going to go ahead and distribute. So I have negative 1/2 times x is negative 1/2 x. Negative 1/2 times negative 1 is a positive 1/2 plus 4. So we can write this a couple different ways. We can go ahead and simplify and say it's y equals negative 1/2 x. We could write plus 4.5, or we could write plus 4.5. Either way is correct. And that looks, we want to double check. Yep, that looks like our equation. The y-intercept easily looks like 4.5, and our slope is negative 1/2. All right, let's move on to 8. Write the equation of the line that represents the data. Oh, warning, warning, warning. I mean, it's a good warning, right? Look, x is equal to negative 8. 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 What's the name of this line that the table represents? X equals negative 8. Okay, if you didn't see that, if you weren't observant, then you would have to do the hoops and find the slope. It's a mess. Please be observant and notice when we have a special table like this. Okay, warning, warning, number 9 also is a really special question, because here x equals negative 4 and x equals negative 4. So the name of the line is x equals negative 4. There's a couple of other ways you could have done this. Besides the long way, maybe you could have graphed them, and when you connected the points, you saw that it's the line x equals negative 4. I hope we have a lot of those on the test, because those are easy and fun as long as we are observant. Okay, so here's a problem with this table. There are two, when we start doing our hoops, there are two problems. Ooh, Not good. Ooh, not good. We could turn these into fractions, I'm sorry, into decimals, but with the 3 on the bottom, it's going to give us a 0.333, and we don't like that. So you're going to love this. I'm going to tell you to take your pencil and ignore that point and ignore that point. We have enough points at our table that we can go ahead and do the hoops without the messy ones. So here we go. -2 minus a -3 is 1. -3 minus a -5 is 2. 6 minus 3 is 3. 3 minus a -3 is 6. So once again, it's rise over run, so it's y's over our x's. So our slope, you can either write it as 1/3, because 1 over 3, or 2 over 6, that's the same thing, right? But 2 over 6 is not in simplified form, so I'll stick with 1 over 3. And then it's as simple as picking a point. Let's go with 6, -2. Once again, if you went with a different one, in your work, we'll still end up with the same equation as the answer. So once again, we've got the long formula. So we've got y equals 1/3, x minus, and plus, oops, there I go again, plus a -2. I'll fix that on my next line. Let's go ahead and distribute. So we'll have 1/3 x. Then if you did 1/3 times a -6 in your calculator, you get a -2. And then instead of writing plus a -2, I'm just going to write -2. So I'm almost done. The very last thing I have to do is combine these two last terms, so two like terms. So -2 minus 2 is a -4. And there you got it. That is the equation that this table represents. We didn't even have to do any of the messy parts of the table, and we still ended up with the answer. So it's always an option to do, as long as you have at least 2 sets of data points on a table. You can get rid of the yucky ones. All right, 11. I know you can see me in front of the class putting my arms out saying, why does y equal 5 have to look like this? Once again, these should be the nice, easy ones that you see. Whoops, dropped my mic. Okay, so when you see this, it's y equals 5. Write an equation of the line that passes through the points -2, -1, and 8, 3. Once again, we are practicing like crazy, aren't we? We're going to put these points in a table. You know, I hope they're right when they say practice makes perfect, because we are doing a lot of practicing. They are right. So here we go, -2, -1. We're going to put in table form.
Autumn Shannon, please report to your ride by the flagpole.
We're going to put 8, 3 in the table, and then we're going to do our hoops. So we'll have 3 minus a -1 gives me a 4. 8 minus a -2 gives me a 10. So my slope is going to be y, the change in y over the change in x. But we know that's not its most simplified form, so we could simplify it a little bit more, and we could simplify it to 2 over 5. And then let's pick a point. Since 8 and 3 don't have any negatives, let's go ahead and pick 8, 3 for our point. And let's extend the page a little bit. All right, so you know what we're going to write. The long formula. And we're going to start plugging things in. So y equals, we see our m, we're going to plug in 2/5. We have x minus, and then h is going to be our 8. And we have a plus k, so it's a plus 3. So we'll go ahead and distribute. So we'll have 2 over 5x. And then we're going to have what? -16 over 5 plus 3. If I put the -16 over 5 in my calculator, I'm going to have to stop writing to be able to do this. Okay, so in my calculator, I'm going to change, let's see, I'll put -16 over 5, and then I'll multiply oh, I'm sorry, I won't multiply. I'm going to add that to 3. It gives me negative 1/5. So I could go ahead and put negative 1/5, or if you wanted to change that to a decimal, you could put minus 0.2. Okay. All right. Write the equation of the line graph below in slope-intercept form. Unfortunately, this is one of those lines that does not have a clear y-intercept, and so we've got to pick our corner points. Where are my corner points? All right, there's one. There's one way up there. All right, so let's see what the slope is. I go up 2. Up 1, 2, 3, then over 1, 2, 3, 4. So my slope is up 3 over 4, but then when I look at the line, yes, if I write my name on it, it's going downhill, so it's a negative 3/4. And then we're going to pick a point. This point right here, his name is over 2, up 2, so his name is 2, 2. 2, 2. What do ballerinas wear? All right, so our point is 2, 2. So here we go. We're going to put the long formula up. And we're going to plug and chug. So we'll have y equals negative 3/4, x minus 2, and then plus 2. So as we distribute, we'll have
Miles Urban, please dial
negative
57610.
negative 3/4 x plus 6 over 4 plus 2, and we extend that a little bit. So if we go ahead and add 6/4, which is really what? 3/2, so that's 1.5 plus 2, that should be 3.5. That sounds good, doesn't it? Okay. See, there's another one on this page. Nope. Okay. Write the equation of the line. Okay, this is not pretty. The other table, we had enough points on the table to get rid of the ugly ones. I shouldn't call them ugly, but the fraction, the mixed numbers. But in this case, we're going to do what we did in class. And since 1/4 is not bad, since when you have 4 as a denominator, you can change that in your calculator to a nice decimal. So 8 and 1/4, if I put 1/4 in the calculator, I get 0.25. So 8 and 1/4 is 8.25. So what we're doing is we're rewriting these. 3/4, if I put in my calculator, is 0.75. So we're going to have 3.75. Here, negative 3/4 is just negative 0.75. Here we're going to have negative 5.25, and here we're going to have negative 9.75. And so we're going to get out our calculators when we do our hoops, and let's see, we'll have negative 9.75 minus a negative 5.25, and that gives us a negative 4.5. And so then negative 0.75 minus 3.75 also gives us a negative 4.5. And same thing here, 3.75 minus 8.25 gives us a negative 4.5. And then on this side, we've got 4 minus 3 is, okay, I gotta remember not to hit that blue thing when I write. 4 minus 3 is 2, 3 minus 1 is 2, 1 minus negative 1 is 2. So our slope, let's go back up. Our slope is negative 4.5 divided by 2. And so if we put negative 4.5 divided by 2 in our calculator, we get negative 2.25. Okay, not the prettiest of slopes, but that's okay. Which point do we want to pick? That's a good question. They've all either got negatives or fractions, so we could just pick the first point. We could say we're going to use the point negative 3, 8.25. So it's messy, but it's the same thing we do over and over again. So we have y equals m times x minus h plus k. We're going to plug in the negative 8.2, I'm sorry, the negative 2.25. Then we're going to plug in the negative 3, so we'll have minus a negative. Then I'm going to plug in the 8.25. Once again, when I see myself having written minus a negative, I know minus a negative is a plus. So I come back to change that before I start distributing. So when I distribute, I've got y equals negative 2.25 times x is negative 2.25x. Then negative 2.25 times 3. I'm going to use my calculator. Let's see, 2.25 times 3. So it's going to give me a negative 6.75. And we're adding that to 8.25. So we're almost done. So let's see if we have a negative 6.75. Oops. Negative 6.75. And we add an 8.25. We get a positive 1.5. That is the name of the line that this table, this crazy table, represents. Let's see if we have another one on this one. Nope. Okay, and number 15, once again, this is a graph that doesn't have a distinct y-intercept, and so we are forced to find corner points. So let's find the corner points. There's one. There's one. Wow. Okay, let's see. My slope is 1, 2, 3, 4, 5. So I rise up 5. I run over 1, 2, 3. So 5 over 3. And let's pick a point. This point looks fine. That point's name is 2, 1. So there we go again. We're going to plug in 5/3 for the slope. We're going to plug in 2 for h and 1 for k. Okay, so I'm going to go ahead and say negative 10/3 plus 1. That's going to be, let's see, negative 7/3. If you did it in the calculator, you'd probably get a decimal that you'd have to round a little bit, or you could leave it in fraction form. Either way is okay. Does that look? Let's see, negative 7/3, that's going to be negative 2 1/3. That certainly looks, the y-intercept really does look like negative 2 1/3, so we're looking good. Okay, and 16. Is 16 our last one? Let's see. Woo, 16 is our last one. This is awesome. All right, so a lot of decimals, but that's okay. We can do decimals. 2.3 minus a negative 0.2 is going to be 2.5. Minus a negative 0.2 minus a negative 2.7, that's going to also be 2.5. Let's see, negative 5. I'm going to pick up the calculator. It's been a long day. Negative 2.7 minus a negative 5.7. That's going to give me a 3. Negative 5.7 minus a negative 8.2. That's back to 2.5. So we had a little bump there. Let's see. And negative 8.2 minus a negative 10.7. It's going to give us a 2.5. Okay, so unless my calculator and I are not operating correctly, we should also have a bump in the axis. So let's see. 2.8 minus 1.8 is 1. 1.8 minus 0.8 is 1. But 0.8 minus a negative 0.4 is actually 1.2. And negative 0.4 minus negative 1.4 is 1. And we've got another 1. So I imagine that 2.5 over 1 would be the same thing as 3 over 1.2. Let's see, let's take 3 divided by 1.2, and yep, that gives us 2.5. So we know our slope is 2.5. Okay, so that's our slope. And let's pick a point. All the points are lovely. Why don't we go with these points over here? They're both positive. So that's a 2.3. Once again, when we see f of x, that's just a y. It's another name for y. We learned that, I believe, in our first unit. So 2.3 comma 2.8 is our point. And we're going to go ahead and plug those into our long formula. So we're going to have y equals x minus h plus k. I think I'm going to be able to do this while I'm sleeping. I've done it so many times. All right, so y equals, my slope is 2.5. My h is 2.3. And my k is 2.8. So we have 2.5x. Okay, let me go ahead and distribute the 2.5 times the 2.3, and we're going to have a negative 5.75. And our very last thing is we're going to have a negative 5.75, and we're going to add to that a 2.8. There we go. All right, and so we've really done a lot. You've either done this with me or you were checking your work with me, and that's great. And so we're just going to do one more thing. On the back of your practice test, we're going to write some reminders. And now, remember, this is your homework, so I'm going to be looking especially for the back of this packet to make sure you've written things down. And so what I want you to write down is parallel lines have equal slopes. Okay, we think about, the windshield wipers that are going the same way. They didn't have parallel lines. They'd be like, intersecting each other and getting all, yeah, it wouldn't be pretty. So parallel lines have equal slopes. And so when they give us let's say for the parallel lines, they give us an old line, we steal the slope and use it for our new line. And then, let's see, different color. Then we ignore our old line. So if they give me a line, I call that the old line. We're just going to steal the slope. We're going to steal the slope, and then we're going to say, see you later. We don't need you, old line. I know it sounds like we're being mean mathematicians, but that's the way it is. So I'd like to see this written down on the back of your partial practice test. Also, let's talk about perpendicular lines. So perpendicular lines let's see. Perpendicular lines they're called negative reciprocals. Their slopes are negative reciprocal, but let's just talk about what you do when a problem says, oh, here's an old line, okay, and make a new line out of this old line, and they give us other things. So if they give us an old line, guess what we do? We steal the slope. Then, we don't use it yet. We take our slope and we do a couple things to it. We, one, make it a fraction. Two, flip it, so we flip the fraction. And three, change the sign. So if it's a positive slope, we make it negative. If it's a negative slope, we make it positive. Okay. Then when we have our new slope, guess what we do to the old line? We ignore it. We ignore the old line. We don't take anything else from it. We just took the slope, made it a fraction, flipped it, changed the sign, and that's all. And then we would go ahead and use other information. So we'll practice parallel and perpendicular lines more when I see you in class. What I expect is when you come into class, you will have all of your partial practice tests done and corrected because you watched this video, and you'll have this information on the back sheet, and that's how I know that you've watched this. All right, thank you so much for joining me. I look forward to seeing you all in class.